Hello, I'm Toni Schindler and I work at Wolfram. Today I'm going to introduce you to Wikidata, the large and diverse dataset that everybody can edit. And I'm going to present to you upcoming Wolfram language functionality with which you can easily retrieve and query that data. Okay, let's start. Hi, I'm Toni. I work at Wolfram, and today I'm going to introduce you to Wikidata and new functionality that we are developing to easily access it. So who of you knows Wikidata? Who has edited it before? Well, one person, great. So first of all, what is Wikidata? And to get you an idea, let's just look at one example. Yeah? So here you see a so-called item. An item has a number, a unique identifier, and it has a label and a description in various languages. Yeah? It has statements, for instance, instance of, which is itself an identifier, which has labels and descriptions in different languages. For instance, this statement says that this item is an instance of the class of humans. Yeah? And human also has multilingual labels and descriptions. Those labels and descriptions anchor the meaning of that item across different languages. Yeah? If you continue, you'll find that date of birth has two different values, probably because different sources use different calendars. So they might actually be the same values, but different sources claim those different values. Yeah? And that's totally fine because Wikidata stores statements, not facts. Statements is what other people say, not what is correct. Yeah? If you scroll further down, the long list of statements associated with that important item about Isaac Newton, you'll find a new section of identifiers. And those identifiers include the Virtual International Authority file, links to the German National Library, the Library of Congress, the French National Library, and so on. Yeah? That's a long list. And if you go further up, or to the right in this case, you'll see the links to Wikipedia pages. And even if you don't know Wikidata, you should know Wikipedia. Yeah? And on Wikipedia, you see those info boxes on the right. Yeah? So where's Wikidata being used? First of all, it's being used for linking different language versions of Wikipedia, but also to, in some Wikipedias, at a community's choice, to populate info boxes. And that is great, because some German might be entering a birth date of an Argentine composer, and it was wrong. But some Spanish-speaking person might notice that and correct it. So more eyes on the same data. And fixing it in one place fixes it in all Wikipedias that choose to populate their info boxes using Wikidata. Yeah? Another application is Wikimedia Commons, which stores images and movies and other documents. Yeah? And a new feature are the depict statements. Yeah? That means machine-readable data of what is in the image. Depict is just the first property of a set of properties that's going to be supported in Wikimedia Commons. Yeah? And the objects of this statement are terms from Wikidata. Yeah? So Wikidata has a nice ontology, a huge ontology, and you can pick the terms from that ontology to annotate images in Wikimedia Commons. And now that you have all of those items, and I'll tell you how many there are, you might want to search for them instead of manually going through them one by one. Yeah? And that's what the Wikidata query service is about. Yeah? So maybe bigger. Yeah. So the Wikidata query service allows you to enter Sparkle queries, yeah, to search through all of the data. And then you can produce, for instance, maps or other visualizations or just the raw results. Yeah. And what about the contents of Wikidata? So each item, that means each identifiable concept in the world that the Wikidata community considers notable enough, gets a running number. And the first item created on 29th of October 2012, that means 7 years ago, happy birthday Wikidata, was the universe. And the second item was Earth. And item number 5 is the class of all humans. Then there's a particular human, the class of chemical compounds, the unit meter, length, caffeine, which is an element of chemical compounds. Then another human, the concept of physical quantity, a snowflake, a movie, the first detected gravitational wave, now skipping 40 million items to go to a scientific article written by that human. So how do you make connections between all of those items? Using properties. And here's a very small selection of properties that you could use. Those properties are curated by the community. A member can't just create a property to not spam the system, but usually they propose a property, try to convince the community that it's a great property, and someone else is allowed to create it if there's consensus. For instance, one of the first properties was image. But there's instance of, subclass of, part of, which are important for modeling ontology. Other famous properties are date of birth, date of death, or a more general property like inception, because a building was not born, but it was built. And then there are external identifiers like an ISBN, quantity-valued properties like population or mass, or the Wolfram language entity code, which means given a Wikidata ID, you can go to entities. And here's a quick overview of how many properties there are. Over 6,000, and this is a list grouped by data type, so over 4,000 external identifiers. That doesn't mean 4,000 values. No, that means links to 4,000 different databases or websites. And then items, links between items, let's say a person to their teacher or university or city they were born in. Quantities like area, mass, and so on. Strings, other important things like time, including dates. Geoshapes. And how do you get access to this wealth of data? Well, there's a new functionality, not in the beta yet, but hopefully coming soon, Wikidata Search. You enter an item and you get a keyword search through the labels of the items in your default language, in this case, English. If you would include all the languages, you would get too many items. But there's an option in which you can say, let me look through German labels only. And this is the item I was looking for. It says British physicist and mathematician. Yeah, that's the one I wanted. So Isaac Newton. I found the item. And then I look for the property. It's similar to Wikipedia search and data, the functions that already exist, but in this case for Wikidata. So you look for the property birth date, and you also get an identifier identifying that particular property. And then the super function that I'm introducing today is WikidataData. You give the item and the property, and it takes care of querying the Sparkle endpoint of Wikidata, dealing with data types, even complex values stored in different nodes of this large graph. In this case, it's a simple case. You get a date object, but we'll see more complicated examples. So you don't have to know Sparkle, but for the experts, I'll now and then show a little bit of Sparkle. So how would you query directly the Sparkle endpoint of Wikidata, or in general, any Sparkle endpoint of the growing number that exists in the world? So you specify your endpoint in this, that's this URL. You specify your query, and just a quick comment, so queries are usually composed of triple patterns. So in this case, you try to find all triples, that means subject, predicate, object, in this large collection of triples that match this pattern. A question mark indicates the start of a variable. And then you find the other matching triples, and then you intersect them. That's in SQL terms a join. And then you continue with that. And there are a lot of query primitives in Sparkle. And then using functionality that I presented last year, Graph Store, you can actually send that query to Wikidata, to the endpoint, and get as a result a list of bindings. They are represented as associations, so this variable item has one solution. this URL. Yeah? So in the semantic web, we identify concepts by URIs. And in this newer version, we use the URL wrapper. Yeah? And the position is a nice geoposition, and you can plot that using GeoListPlot, for instance. Yeah? So this map is showing the charcoal-powered charcoal power plants in Germany, so I wouldn't want to live around Dortmund, I guess. But a more sophisticated query would take into account which of the power plants have shut down now. Yeah? But it's just for illustration. So now, more complicated data types. Yeah? So this little query introduces many more features. So you can have a list of identifiers, in this case the Eiffel Tower, a proton, and a particular star, and request a mass for all of them, and make an association. So WikidataData is just like entity value, just for Wikidata. Yeah? It supports the nice syntax. And what you see is you get quantity objects back, which means you can compare them and place them on a plot. Yeah? And you see how the proton is lighter than the Eiffel Tower, which is lighter than that star. I'll show you later what the difficulty is with that and how it's been solved. Yeah? So the next idea of Wikidata, as I mentioned before, is the idea of statements. You don't just get values that are true, because what does truth mean? So you get just statements, which means under certain conditions, formulated as qualifiers, and given by a certain reference, that's the value. And Wikidata has the model of standard rank values, preferred values, or deprecated values, which means if an article claims a certain value and it later turns out to be wrong, this statement is not necessarily removed from Wikidata, but just deprecated. That means it does not appear in queries by default, but you can enable it. But a user coming to that item and wanting to enter it finds out that, well, that value has been claimed indeed, but it has been deprecated. So the user learns something. Yeah? But you can imagine doing fancy queries where you find which journal has published the most deprecated values, whether that is good or bad. Yeah? So in this case, by default, we are getting the preferred value and just the value. But we can say we want a more complete statement format. In this case, association, or an alias for that would be all, yeah, in which we get the value, qualifiers, yeah, in this case, the apparent magnitude of a particular star. Yeah. Here we get the astronomical filter associated with that value, and the references where that value was stored. Yeah. But, yes?
What's the difference between the third argument association versus statement format arrow?
Yes. So the third argument is concerned with how lists of items or lists of properties receive their keys in the resulting set. Yeah? That means if you have a list of items, you get a list by default, but you might want an association where the initial items are the keys. Yeah? This option, which is a string currently, so not fully standardized yet, changes how each individual value is formatted. Yeah? Whether you want more details. Yeah. And in this case, I just say I want all non-deprecated values, and I get just for the single, for the apparent magnitude of a single star, I get multiple values, yeah, that are valid for different astronomical filters, and all stated in different sources. Yeah. So now let's look for a moment at the data model of a value. So if I'm asking for the position of held by Isaac Newton, I could imagine in a simplistic model, I just go directly from Isaac Newton to President of the Royal Society. But that's too simple. Yeah? So the way Wikidata does it, it starts at Isaac Newton and takes the claim predicate associated with position held to go to a statement node. And from that statement node, you go in this simple case to a simple value. But you also go to a reference node, which might link to a book. Or you might have qualifiers like the start and end time of this position. Yeah? And in Sparkle, you would simplistically formulate that as going from the item to the node, and from that node, you extract the actual position, the start time, end time, and qualifiers are not shown because you can imagine references are not shown, sorry. Once you go to a reference, it's just an item, and you might need or might want to know what's the label of it in a particular language. So the query is going to be rather big. Yeah? And then you get this result set, but you'll have to format that nicely. And in the most general case, there's a lot of post-processing restructuring of that result set going on. Yeah? And Wikidata does all of that for you in one single simple call. Yeah? How about time series? Yeah? So now that we know that this statement format association or all, we can request qualifiers. Let's request the life expectancy for a few countries and extract for each of the resulting lists the date and the associated value. So we can make time series out of that. Yeah? And we see that there seems to be a dip. I was surprised because I thought it would always go up. Yeah. But we have to run that query again in a few years, I guess. So what are those white boxes? Those are external identifiers. Those are a new construct that allow us to describe what or in which identifier system an identifier is valid. Yeah? In this case, Q1 is the identifier within the Wikidata identifier system. Yeah? We can include meta information, and if we include, for instance, the label, it is used for display of that identifier. Yeah? Because just the Q1 might be uninformative. Yeah? Oh, by the way, we have links derived from a certain identifier type, because certain identifier types have a canonical URL, yeah? The universe. We also have support for ISBN and a number of other identifiers, like the Music Brains Artist ID or chemistry identifiers. Yeah? So now, given a Wikidata ID, we can take those short identifier type strings, or in case we don't have it, just a Wikidata property to go from an Wikidata ID to another ID. Yeah? But we can also go reverse. Yeah? Given a DOI, we can retrieve the corresponding Wikidata ID or directly properties. Yeah? So all of those 4,000 different identifier types supported in Wikidata, you can use any of them. Yeah? Finally, we get to entities. Yeah? Alpha stores information about how to map certain entities to their Wikidata IDs. That means we can use entities just in WikidataData to get a nice data set about Amazon, the river. Yeah? But we can also do the reverse. Given a Wikidata ID, we can extract the entity and then check out the Wolfram data. Yeah? And there might be a trade-off. This is Wolfram curated data, and there are a few less data points. Yeah? This is community curated data. There's more, but it might have quality issues. So it's up to you to judge what you're doing. Yeah. And, oh, I'm running out of time. So many interesting things to talk about. So a quick refresher. So you might have heard in other talks I gave over the last few years about entity classes. Yeah? And as particular implicit entity classes, in which you specify a certain type and then a list of conditions. For instance, longest rivers in Hungary, you specify the type river and the condition that it should be in Hungary, and you want the 5 largest by length. Yeah? Retrieve the list of entities or make a data set containing data for each of those entries. Yeah? But why stop there? Why not just define those entities implicitly and then use them in Wikidata? And how's it possible to evaluate an entity class on Wikidata? So we have mappings from entity types to Wikidata items representing a corresponding class. Yeah? We also have a mapping from properties and items. So that means this class can actually be translated to a Wikidata query. So this is exactly the same type of information, but from Wikidata. And all of that is evaluated in a single query on Wikidata. Yeah? So it's very fast. So why stop at that level of generality? Why not just allow arbitrary Wikidata items in the first argument of EntityClass. Yeah? So this is the class of SR base units, and I don't specify any condition. And I'm asking for, well, what's the Wolfram language quantity corresponding to it, and what are the measured physical quantities? And you see the candela, that's the Wolfram language unit. And, well, it measures luminous intensities. But you can imagine that process for any kind of unit. So going even further, you can use Wikidata IDs in the property position of an implicit entity class, and for instance, ask for early paintings by Van Gogh. Yeah? Get the image for all of them and make a collage. Yeah? Those are the 16 first images by Van Gogh in Wikidata. 5 minutes. Oh. You can, that also works with your custom entities. Yeah? So before you would probably, if you want to curate your own book library, you would probably carefully enter all of the data in your own entity store. But why actually do that? Why not just enter the entity, the label for nice formatting, and then the Wikidata ID? And then you can get all of the data from Wikidata. Yeah? So no more duplication of that data in your own entity store necessary. I doubt I will get through all of the quantity issues. Oh, that's unfortunate. Yeah. But yeah, just a quick remark. Yeah? Note how I mentioned simple values before. Quantities are more complex. Yeah? So once you go from the statement to the value, in this case it's not a simple value, but it's a value node, which links to the amount, yeah, and to the unit. But units in Wikidata are just items, so how do we translate them to Wolfram language built-in unities? Well, there's a nice new property called the Wolfram language unit code in Wikidata. And that has more than 1,000 values, so it means you can map nearly all quantity value data in Wikidata unambiguously to the Wolfram language. Yeah. And here are some statistics about it that I can't go in, unfortunately. Yeah. But you can read about it. Yeah. Another fancy feature is that, for instance, geopositions might depend on a coordinate system or a globe. Yeah? And globes are also items in Wikidata. And those items are mapped to entities using the Wolfram language entity code. So you can get a fully specified position of something on the moon. Yeah? And here's an example of how this entity code is entered. Yeah? And anybody can fill in more details if they find something missing. Yeah? Something really fancy that is strictly more powerful than GeoIdentify is GeoLookup on Wikidata. Yeah? So you can specify, for instance, physicists born around Ulm. Yeah? That is already impressive. Yeah? But even more impressive is you can use just a GeoDisk to identify things in that area and then add additional constraints. For instance, all the lakes around Budapest greater than that to make a map. Yeah? And now that you know how complicated quantities are, you might be impressed by that query working. Yeah? You're trying to find optical systems whose focal length, yeah, or order them by focal length and take the largest 3. Yeah? And those are given in meters. Yeah? But unit conversions are handled automatically by that query on Wikidata. Yeah? It's a single query. Or you can mask for the smallest ones, and you see they are given in millimeters, but those conversions are taken care of properly. Yeah? Or the rather simple case, finding the latest movies by Tarantino. Yeah? It's just ordering by date, which is fairly well understood. Yeah? Property paths, well, there's actually a design issue. How do you represent property paths? So what you can do is start at the country, go to the capital city, the head of government, their place of birth, and then their country, being Greece. Yeah? So that can be evaluated, but then how do you extract the head of government in a single query? Yeah, so I leave that as a homework. One really fancy thing is last year I introduced symbolic sparkle or presented symbolic sparkle. And if the implicit entity formulation for queries is not sufficient for you, you can use your own symbolic sparkle to define the entity set and get all of the fancy Wikidata features for free. Yeah. And now to conclude, what is Wikidata actually running on? It's a software called Wikibase, and it's open source software. And some large organizations are investigating using Wikibase for their own datasets. For instance, the German and French National Library. So wouldn't it be great if you could use the same functionality to query that data? And well, yes, and here's actually a prototype that won't be included anytime soon, but just to show that it works. Yeah? So Wikibase is encapsulated in a Docker container. You can just get it and start it, and I actually did that for you. Yeah? And then you can simply enter to the main page and create your own items. Yes? Special pages, and create a new item. Yeah? And that's just a Wikidata workflow. Yeah? I'll finish in a few seconds. So I just created a new item that has a queue number, and there are some internal functions that need to be fleshed out. Yeah? But the idea is that you specify just a configuration, define your own functions that pass this configuration to those internal functions, and then you have your own picture search. Yeah? You find an item picture for rows, and you can use the functionality like get a data set. You say it depicts the rows and it's ordered by Polar. Yeah. Thanks. Any questions?